So let's look at level curves on a function where we really don't know what the graph looks like at all from previous instruction. Z equals x squared plus y minus 2 is not one of the functions you'll see on the list of graphs that we've studied. So we're going to look at the level curves at 3 different levels. What if we were at level 0? So we'll do z equals 0. We'll also do z equals 2 and z equals 4 and see if there might be some sort of a pattern that we could determine by looking at it. So if z is 0, we would get 0 equals x squared plus y minus 2. Subtract the x squared, add the 2, y equals negative x squared plus 2. Well, wait a second. I know that graph. That graph would be a parabola. All right, so that particular parabola x-axis, y-axis, if that's 2, this parabola would look something like the following. I don't know exactly what the three-dimensional graph looks like. I mean, I don't really know what this surface might be. But I know if you slice it when z equals 0, you're going to get a parabola cross-section. If we let z equals 2, 2 equals x squared plus y minus 2, I think you will find that y is equal to a negative x squared plus 4. Y, that's a parabola also. So we'll call that 4. And it would look something like this. So if I go 2 units in the z direction and slice the graph horizontally, I'll get a parabola cross-section again. If I let z equals 4, 4 equals x squared plus y minus 2. Add the 2, subtract the x squared. That would be negative x squared plus 6. That's another parabola. Whatever this graph looks like, if you slice it higher up, lower down, you're going to get parabolas, and the vertex appears to be shifting by the same amount as the z value. So if I increase by 2, the vertex moves 2 units up. That's what it would appear to be. I wonder what this graph looks like. So the directions are satisfied once I've sketched this. If I had graph paper, these would be made better. I would probably plot the x-intercepts with the vertex to make a better symmetry. This side looks like it melted in the heat. It is not my best demonstration of drawing, that's for certain. Let's pause this and switch over to GeoGebra and see if we can't get a better look at what's going on as we increase these higher and higher levels. Now here is the actual picture of the surface in 3 dimensions. Z equals x squared plus y minus 2. And there is the parabola we would get if z is 0. It's where it hits the ground. It's where it hits the ground. Ooh, I kind of see that shape, but it's moving down sort of at a diagonal. If I were to look at when z equals 2, I can see another parabola that is 2 units higher than before, whose vertex is 2 units higher than before. If z equals 4, there it is, vertex is 6, the cross sections 4 units up looks like this parabola shape. Now, I may not be asking my students to graph this particular shape, but I hope you can see how the level curves allow us to start to imagine the third dimension without having to draw the third dimension. Fantastic. See you later.